Remember that before we fit a model to the datasets, we have done a simple outlier detection on each dataset. And actually, it is also possible to run an outlier detection on the results after fitting a model. And the stat_gene star package actually provides a function called outlier star for doing this. Okay. This outlier detection checks the residuals in the fitted model and compares them to a limit. Observations with a residual higher than this limit are marked as outliers. And the default limit is calculated based on the number of observations in the data. Okay. So for example, let's have a check on the outliers for model 1. Okay. Outliers put to the function is called outlier star. Now we put model 1 here, and then we put traits put to, and then what is fixed, because we will fit a model with genotype as fixed effect. Actually, it's not necessary to put a fix here because we only fit one model, just the model with the genotypes of fixed effect. And let's set verbals equal to false. And this will suppress the output so that the output won't be printed out because the output is very long. So it's outlier, it's not our liar. Outlier. And you can see the output, this object, the outliers. This is a list of 2 items. Actually, let's take a look at each of these 2 items in the list. So the first one is called indicator. So actually, this is a vector of indices of outliers in the original data. For example, for the first one, so the 66 means that the 66th observation in trial 1 is considered as an outlier. Okay? And if you want to remove this outlier, you just remove the 66 observations. Okay? And the other item is outliers. So actually, the outliers is a data frame. Okay. Maybe let's do view. This data table has all the original columns but only contains the outliers, and these observations are considered as outliers. And to get an idea of the magnitude of the outliers, we can use the parameter common factors in the function to see the values of observations with similar characteristics. So here, for example, let's do outliers 2, model 1, 7, 5. But with the common factors equal to genotype. And also we can set the limit for determining when a value is considered as an outlier, which can be done by setting the argument R limit to be some value, let's say 3. Okay.
see the output. This table is sorted by genotypes. You can see the same genotypes are put together. And if the residual is greater than 3, like this one, it's considered as an outlier because we set our limit equal to 3. And in this package, there is also a report function available that creates a PDF report summarizing the main results of the fit model. And also the text file and figures used for generating the PDF report are saved. Here, let's try to generate a report for model 3. Report model 3, and the second argument is called Outlier. For this Outlier, we'll put the path of the directory where you want to save the report. Okay. So we'll do report model 3 report PDF. Okay. And again, we can use what argument to specify which model we want to create a report for. Genotypes as a random or as fixed effect. And here, let's do what equal to random.
Okay, here's the PDF reports that was generated by that function. So the reports contains the general information on the model fitted and a summary of the results and the plots described in the previous sections and a list of best 10% genotypes, okay, and a scatter plot of all genotypes and their blues or blobs. And after fitting a model, various results can be extracted or calculated from the fitted model using the function extract. The results that can be extracted depend on the type of model fitted and sometimes on the modeling engine as well. For example, blues can only be extracted if genotype was fitted as fixed effect, and on the other hand, blobs and heritabilities can only be calculated and extracted if genotype was fitted as random effect. And all results that can be extracted are shown in this table. In the first column is the result, and this is also the value to be used for the parameter what in the extract function. And the second column shows what model needs to be fitted in order to be able to extract the result. Here, F stands for genotypes as fixed effect, and R for genotype as random effect. And the last column gives a short description of the result that will be extracted and also states for which modeling engines it can be extracted.
Okay, let's try to extract some results from the fitted models. For example, we want to extract blues from model 1. Okay, so we'll do model 1 blues. We'll use the function called extract sta. Okay, and this style object is our model 1. And because we want to extract blues, so we'll let what equal to double quotes blues. Okay. So you'll see we'll have a data set with 3,235 observations with 3 variables, 3 columns. So the first column is the genotypes, and then the trial, we have 4 trials. And the last one is actually the blues. Okay, so this is blues from model 1. And next, let's extract blobs from model 3. Okay, so we'll call it model 3 blobs, and again use the function extract sta, and now the stat object is called model 3. Okay, and we'll let what equal to blobs. Okay, so now you'll see another data set with 16 observations and again 3 variables. So the first column is genotypes and then trial. The last one is blobs. Okay. Also, in addition to blues and blobs, as we see from the table I just showed you, we can extract some other statistics that we may need. For example, we can extract the variance components for the model with genotypes as a random effect by letting what equal to var comp r. So let's try that. So it's model 3 vars, okay, because we want to extract the variance component. Now let's do that for model 3. Okay, so put the star object as model 3 and we'll let what equal to so-called var com r. This gives us the variance components for the model with genotypes as a random effect. Okay. Basically, it gives us the residual sum of squares, also the various components for genotypes as block. And for this warning message, you can just ignore it because the extract star function, it will convert the output to a data frame if it's possible, but if it's not possible, it will remain as a list. So this model 3 vars is a list instead of a data frame object.
And using this data frame, we can do some additional analysis. So for example, we can do ANOVA test for the difference of trial means with checks removed. Okay? So let's first find checks. So let's again do this for the first data set. Okay. Checks data 1.1, and we'll use the function filter in the dplyr package. Checks not equal to 0. Okay. Then we create a vector called genochecks, and we do the unique of this data 1 checks. Because we want to get the genotypes that are checks. Okay. And then let's remove these checks. Okay. So let's call the new data set this no checks. Okay. And we'll do this from this data frame of blues from model 1. Okay. And again, we'll use the filter function. So we'll select the genotypes that are not in this genochecks vector. Okay. So in R, when we do not, we can use the this and genotype, we do percent in percent. That means genotype in the vector genochecks. Okay, so this means we want to select the genotypes that are not in this genochecks vector, where this genochecks vector contain all the genotypes that are checks. And let's run it. We can, and then we can do an one-way ANOVA test. So we'll use the LM function. The formula is Bruce trials because we want to compare the trial means. And then data equal to this new data frame, data set. And then we do ANOVA fit. Okay. Now we can see this is a result. Okay. The residual sum of squares and the F value. And we can even do pairwise comparisons between trials using the EM_means function in EM_means package. Okay. Let's do pairwise comparisons between trials. So let's load the EM_means package. And then we do use the EM_means function to fit. So the fit is just this linear regression model. Fit to trial. Okay, and that's it. And let's run it. Okay, we need to first load this. Library. And let's see, what is this? So you can see this is the EM_mean for each of the trial with the standard error and the lower and the upper confidence bound. And to do the pairwise comparisons, we just use the pairs function in the EM_means package, and we put this one Bruce EM_means there. So this gives you the result of the pairwise comparison. So 1 compares with 2, the difference is 3.08, and the standard error, and also the t-value and the p-value are all available here. And this is how we do pairwise comparisons between trials.